All right, good morning, everyone. Welcome to the session on programming with Lambda expressions in Java. My name is Venkat Subramaniam. We're going to talk about some really exciting things that's happened in Java. Well, this is a bit of a surprise for myself because I was one of those guys on the other side of the picket line, constantly complaining that Java simply sucks. And for me to see that there's actually something exciting in Java has been really a fun thing to watch. Let's think about what's happened in Java. Way back in time, the first time after Java was released, when Java really had a good update was in Java 1.1 timeframe. We had anonymous inner classes. And then came along a whole lot of nothing. And then Java 5 had some exciting features, but somewhat controversial, like generics and auto-boxing. Java 6 had no features at all. Java 7 had one of my most wonderful features I liked really. You can put underscore in numbers. As I'm aging, that's a feature I tend to rely quite a bit. So absolutely, there's not a whole lot that happened. Well, that's all about to change, and that did change. Hey, Josh. And that changed in Java 8, and we're going to talk about that here today. So the big thing in Java is really Lambda expressions, but a lot more than that, as we're going to see here today. So what's a Lambda expression? Lambda expressions are really anonymous functions. They really are actually cute little anonymous functions. And we can pass them around as first-class citizens like we're used to passing objects. So in other words, we have higher-order functions in Java. So we are used to passing objects to functions. We are used to creating objects within functions. And we're also used to returning objects from functions. Now we can do with objects functions that we are used to doing with objects. So we could pass functions to functions, we can create functions within functions, and we can also return functions from functions as well, and that is something we could do very easily in Java. The lady in the front, don't sit down right there yet. I have a chair for you. So you get the first class seat. How about that? So there you go. So what we have in this case is the ability to really not just do object composition, but also do function composition as well. So we're going to talk about quite a few things, but I request you to ask questions along the way. When you have one, please don't hesitate, and definitely please don't wait until the end. I won't be taking questions in the end, but anytime during the talk is a great time for your questions or comments. I would love to hear what you have in mind. So let's start with a little example. I'm going to start with an example that we all have done a million times. And we're going to try this out, but in different ways, slowly changing one thing at a time, going from familiar to something a little different, and then get familiarized with that, and then we'll refactor it about 5 or 6 times as we see. So let's try this out. Let's say we have a collection of numbers for a minute. So I have a collection of integers, let's say, and we'll call it numbers equals, let's say arrays.asList, and I'm going to deal with just a few numbers on my hand. And I want to go through and start iterating through these values. So how would we go about iterating through these numbers? We would say if int I equal to 0, and then we would say I less than numbers dot size, length, count. Anybody remembers what that is? Size, are you sure about it? Okay. Is it less than or equal to? What should that be? Is it less than? Is it ever less than or equal to? Sometimes. So while you're writing this code, how do you feel about it? And then we say numbers.get. So anybody here into patterns, design patterns? Love it? Well, there's a pattern name for it. It's called self-inflicted wound pattern, right? That's how it feels, isn't it? Well, why do we go through such amount of complexity? People will look at this and say, hey, that's a simple for loop. They clearly have misunderstood the term simple. So I would argue the word they are looking for is not the word simple, but the word familiar. Because this is a very familiar for loop, but it's nowhere near simple. In fact, I would argue this is one of the most complex pieces of code we could actually write, because you first have to initialize I properly, you got to set the boundary conditions properly, you got to increment the variable properly, and get the value out of the index properly, and all that to do a very trivial task of iterating through a loop. So Hey, I'm seeing you in there, so you're nodding. That's good. Absolutely. So essentially, the idea really is that we really are writing a very complex piece of code. There's no reason to deal with this kind of complexity. Now, of course, the code produces the right result, and we can see the result, great. But let's refactor this just one more time. And what we're going to do here is use what's been around for quite a long time, known as the for each. And we can say if int e is an element in this collection called numbers, and of course I want to just output the value, and notice that was a lot simpler to write this code. Now Occam's razor says if two solutions yield the same result, we should go for the simpler one, because obviously that's much easier to work with, understand, maintain. So the idea really is both of them yield this result, the same result, but of course this is a lot better. This of course we know as external iterators. Now what in the world is an external iterator? External iterator is like having a rude dog. You say move and it doesn't budge. You have to literally push it with your legs, right? That's how it feels. You got to do a lot of work to get things done. But thankfully we don't have to work with external iterators. Instead what we could do is we could use what are called internal iterators. So an internal iterator is like throwing the frisbee and the dog goes at it. So the main idea behind internal iterator is it relieves the burden off our shoulder in focusing on the looping, but instead we end up saying exactly what we want, that is what to do for each of the elements in the loop. Let's go ahead and try that out real quick in Java. So what I'm going to do here is I'm going to say numbers.for each, and let's stop right there and take a look at this for a minute. We haven't implemented this yet, but look at the syntax of what we are doing right now. Syntactically, that's not different at all. We have done this for a long time, but semantically, it is a huge difference in what we are doing. Because what we are doing in this case is we are not passing. Take a look at line number 7 and line number 10 for a second. In line number 7 and 10, we are passing the collection to the for loop. On the other hand, in line number 16, we are invoking a method on the collection. Now, we know one thing that we get when we invoke methods on objects, we get to enjoy polymorphism. Now, polymorphism does a lot of good things. Look at line number 7 and 10. What do those two lines say? We'll do exactly what you asked for, period, which is loop through sequentially the collection of elements, and you get to manage the looping. Line number 16 says you can loop, and I'll take care of the looping aspect. You tell me what to do per element, and you don't have to really worry about the looping itself, which means can the looping be sequential? Can the looping be concurrent? Can the looping be whatever it is? And the answer is yet it could be any of that. And in other words, we don't control the looping. We focus mainly on what to do and not how to do it. So let's see how we can go. We're going to implement that in a second. So for this, I'm going to go ahead and send to it a new consumer. Now, what in the world is this consumer? I'm going to go ahead and import right here stream.consumer right here. And once I bring in the consumer, what I'm going to do is ask the consumer to implement this. So I'm going to say integer, and this is going to be a public void accept method, which accepts an integer called value, and I'm going to simply output the value right here. So we went from an external iterator to an internal iterator in this case. So consumer basically is the object I'm going to use over here. Let me make sure I spelled it right real quick. So that's basically what we are bringing in this case. And the consumer is going to have a method called accept, and I'm going to pass to this a value. So how does this go about working in reality? Well, for each method is an internal iterator. It accepts an instance of consumer. Now, consumer, of course, is an interface, and we implement an anonymous inner class of this. And in the accept method, we are accepting a value that the for each method continuously provides to us. And all we are doing in this case is we are simply asking it to go ahead and print the value that we are receiving in this particular context. So when we go ahead and run this code, you can see it produces exactly the same result as the other piece of code. But what did we do? Rather than focusing on the looping itself, we simply relied upon what to do per instance of the loop. Now, the benefit in this case is we enjoy polymorphism. We cede control in terms of how the iteration actually works. We focus on what to do and not how to do it. We can enjoy all the benefits I talked about. I know what you're thinking while I'm saying this. You're saying, all right, Venkat, you said all these good things, But in order for us to get all these good things, if we have to implement yet another anonymous inner class, heck no, right? Is there anybody in this room who wakes up in the morning and says, yes, today is the day I'm going to go to work and write another anonymous inner class? Right? If anybody raises the hand, I want you to leave the room right now, right? So absolutely no. In fact, to the contrary, if that thought comes to your mind, you call the boss and say, I'm very sick today, right? You don't get excited about doing stuff like this. So this code is an example of a very high ceremony. Now you look at this code and say, what is this concept in Java? Well, people will tell you this is called anonymous inner class, but the right words to use in English is missed opportunity. Because that's what it really is. Back in 1.1, rather than doing anonymous inner classes, we should have gone the route of really Lambda expressions, right? So at least finally we can catch up to it. Well, thankfully, we don't have to do this. So what we can do is, let's focus on this code for a minute. This is called the ceremony. This one line here, that one single line is the essence. What do we want to do? Now, what is around it? What is around it is called the ceremony. Now, what in the world is ceremony? Ceremony is what you have to do before you get to do what you really want to do. Anybody here who gets excited about ceremony? It's like, no, I don't want to do this. No, you got to do it. And by the time you go through the ceremony and get to the end of it, you don't even remember why you got there in the first place, right? So that is the point. Ceremony beats you down. Well, let's go ahead and try this one more time. So we're going to say in here, for a difference, we're going to say numbers again, but we're going to call the for each method, and now we say integer value. Now what is that? That is exactly the parameter list that you see here. So we stripped out everything around it that is a ceremony and got directly down to the essence. Then we say here, now that we have defined the parameter list, here is the body of the code, which is exactly this line of the code that we are interested in. And I'm going to move that down here, and we grabbed just the essence versus the ceremony, and we got rid of the other things around us. So what did we just have? We have an anonymous function. Now, most of us would argue that a function has four things in it. A function has a parameter list, it's got a body, it's got a return type, and of course it's got a name. Of these four things, we would argue that the body is the most essential thing. Well, the body of this function is the right of the arrow. So what follows the arrow is the body of the function. The left of the arrow is the parameter list of the function. So 2 down, well, the return type is inferred in this context, and who cares about the name when all the work is done? So we don't have a name for this method. So this code actually works, as you can see, produces exactly the same result as the other code. So in other words, anywhere a SAM or a single abstract method interface is expected, now we can send a Lambda expression in this code, as you can see right here. Well, that's great so far, but there's still one other problem we are dealing with in this case. If you look at this code for a second, now, what in the world is numbers? Do you know what numbers is? It's a collection of what? Integers. You know it. Does Java know it? Absolutely, right? So Java knows it, you know it, and why in the world are we saying it's an integer? Now think about it. If you're iterating through a collection of integers, guess what this would actually be? The integers, right? What in the world else can it be? So this is like, every day we go through it, but we got to kind of shake the hand and say, yep, I still love you, right? So the point is, you got to get beyond that after a while, right? So there's a bit of a trust we have to build. So right here, fortunately, we don't have to do that. So I got some good news for you. We could simply say for each, and we could say value, and then we could simply output just the value, as you can see right here. So notice what we just did. We removed the type information. So for the very first time in a long time, Java is finally intelligent. So we don't have to specify that information anymore, and it kind of infers based on the context. Well, that's great so far, but why the ceremony of the parentheses? After all, we can get rid of that as well. In a context of a single parameter list, it allows us to do that. So we can get rid of the value right here, and you can see that that still produces the result here. But this brings us to another problem on our hand. And the problem is, if you notice this code for a second, if you look at what's happening in this Lambda expression, let me just grab this Lambda expression alone and put it in front of you so you can actually see it to essentially what it is doing. And if you notice this Lambda expression, what's going on in this Lambda expression? Well, this Lambda expression receives a parameter and simply turns around with absolutely nothing being done to it, passes it as an argument to the print line method. So if you look at this code, there is absolutely nothing intelligent being done in this code except a simple pass-through. So this reminds me of something. Anybody who has watched the movie Office Space here? Oh yeah, quite a few of us, right? Well, remember in Office Space, what happens? They're interviewing and they say, Tom, what do you do here? And Tom says, well, I take the requirements from the business people and I give it to the programmers, right? And then they say, well, why do they need you to take the requirements from the business people and give it to the programmers? And he says, because programmers are not people, right? So this code is kind of like that. It doesn't do anything intelligent. It takes the parameter and simply turns around and passes it. So I call this the Office Space pattern. Now, given this, the seventh time you write this code, you're going to feel utterly stupid, and you're going to really complain about it. But history has shown one thing very clearly to us in the past 20 years. Java programmers never write stupid code. They invent IDEs to vomit stupid code. So the next thing you will notice in this case is people will be tweeting each other, hey, what's that IDE shortcut you're using to spit out this code? And they knew this was coming. So what they did was they made this a lot more elegant. So we can simply say numbers.for each, and you can simply say system.out, print line, and this is called a method reference. So a method reference basically says, I really don't have any manipulation of the parameter I'm receiving. All I want to do is pass through. So the parameter I receive, I want to simply send it out as an argument to this function. Please, yes?
I'm sorry to disturb you.
Oh, not at all. You're most welcome to.
That's incredibly succinct, isn't it? Line 31.
Mm-hmm.
And if you scroll up a bit,
You bet.
where you're creating a new consumer.
Yes.
It's extremely clear that you're creating a new instance of a consumer.
Correct.
Have they done anything? Because if you run that code, say 20 times, line 31,
Right.
you create 31 instances.
That's a wonderful question. That's a wonderful question. I'm glad actually you asked it. This is a fantastic question. So I want to rewind a little bit. I won't have time to go into the details to show you, but I'll give you a hint on along the lines of what they are doing. 50 minutes doesn't quite give me the time to go into it as much as I really want to. Normally when I give this talk over 90 minutes, I actually go into it, but let's quickly talk about it. So if you look at it, that's a wonderful question. If you look at line number 22, you are passing a lambda. So it appears as if it's a syntax sugar where a lambda is simply being replaced by the compiler into an instance of anonymous inner class. And if they did this, this would be a disaster. And the reason is we're going to have a blow up of the jar files, right? So many anonymous inner classes being created. Well, this is where it was amazing to see that they were working on Java 8 at the very tail end of Java 7, and they had implemented a feature in Java 7 called Invoke Dynamic. And Invoke Dynamic was introduced in the first place to help dynamically type languages. But then they realized, how do we solve this problem? And suddenly they realized, oh, we could actually use Invoke Dynamic to route it. So in a sense, when you compile this code and then do Java P minus C and take a look at the bytecode, you will notice each of these for each methods really become an Invoke Dynamic calls. And quickly, Invoke Dynamic says, do not worry about instances and method names, simply bind to a method that matches a signature at runtime. So this is a JIT compiler optimization introduced in Java 7 that helps out in Java 8. Brilliant question, thanks for asking that. So as a result, we don't see the instance being created, the instance is not being created in reality, so much better performance. So in the worst case, you're going to have the same performance as anonymous inner classes, but in an average case, you actually are going to do a lot better than that. Really good question, please.
Despite the name, this is completely different from passing a function reference as a function pointer as you would have in C.
That's correct. And the reason is because we do still have to deal with the legacy semantics of Java. So they went through enormous amount of discussion thinking about whether they should really introduce value types, and there were really good reasons to make that decision. So point well taken. Absolutely, you're right. So we looked at how this can refactor. So let's go over what we just did. We started with the traditional iterator. We then used the for each syntax. We traded external iterators to internal iterator, looked at the high ceremony code. We didn't do a syntactical difference, this was a semantical difference. Then we looked at the for each method and saw how we could actually pass a lambda. Then we looked at type inference, and then we looked at reducing a little bit more of the noise, and finally we looked at the method references. So we went from what was a high ceremony to really a concise format. And once you get familiar with it, it becomes a lot easier to work with. Well, let's go ahead and take a look at one other example here that illustrates this particular concept a little bit further. Let's say we are interested in working with a collection of values, and how would we go about dealing with it. I want to talk about an imperative versus a declarative style along the way. So let's go back to this example for a minute. Let's say 5, and then 4, and then 6, 7, and 8, and 9, a bunch of values. So let's say I want to pick the double. So let's say get the double of the first even number greater than 3. Well, how would I go about doing just that? Let's talk about the traditional imperative way of doing it. We'll say result equal to 0. We would output the result over here. But on the other hand, I'm going to say over here, int element in, we could say numbers, for example. And then once we go through the looping here, we could then say, for instance, result over here. So result equals element times 2. And then we would break out of the loop. So if you notice over here, this produces we need to double the value and print the result, of course. And the first even number, so I want to put some logic in here, of course. So we're going to say e is greater than 3 and e is even number. And then if it is true, we want to do those two operations in here. So if you notice this code, this is a good example of an imperative code. Now, what is an imperative code? An imperative code has two smells associated with it. The first smell of imperative code is mutability. We continuously modify a variable over and over and over. So if you notice this particular example, on line number 9, we created a result equal to 0. And then on line number 12, we are constantly modifying the variable, mutating it. Now, I didn't have the volume up on my computer, but if I turned up the volume, you will actually hear the variable result say, ouch, 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 on line number 12. You're continuously mutating that variable, right? So that is an example of an imperative style of code. The other thing about imperative style of code is, an imperative style of code is something where you have to not only tell what to do, but you have to constantly say how to do it as well. So it's a very low-level procedural stuff you are really getting into in saying, do this, do this, do this, do this, and you got to dictate every single step that you have to follow. So how does this feel like writing an imperative style? It feels like you're constantly talking to a toddler, right? Sweetie, walk slowly, hold it with both hands, look where you're going. So you got to give every step of directions to it. Let's try to rewrite this in a more of a functional style or a declarative style. So I'm going to output right here the result of this call, and I'm going to say numbers dot, and what am I going to start with? I'm going to start with a stream. A stream is a very fancy iterator that's available in Java 8. We are familiar with iterators in Java, and what do? They give you only two things, has next and the next element. Well, this has a lot more to it. One of the operations I'm going to perform on this is an operation called filter. And all I'm saying is, given an element, give me the element. Actually, we saw method references. So let's go ahead and say sample. And then I'm going to say over here, is greater than 3. So then I say filter one more time, sample. And I'm going to say is even. And then I'll call filter one more time. And then I'm going to ask it to get me the element and double it. Well, in this case, I'm going to use another function called a map function. So what does filter do? Filter cherry picks elements from a collection. So if you have a collection of 10 values, and I say filter is greater than 3, it only gets elements greater than 3 and drops the rest of the elements. It cherry picks only numbers that are greater than 3. Then that collection is sent to the next one, and it says only pick even numbers from it, and then the odd numbers are thrown out. And the map method is one of my favorites. It says says, given a collection of input, perform a mapping value of the input to the output. So this is a very nice transformation function. So it transforms an input into another output collection where it automatically applies that operation on every single element in the collection itself and produces the resulting result. And the last thing I'm going to do here simply is to do find first and ask for the result from this collection. Now, this code is a bit more revealing and it's got two benefits. The first is it's declarative in nature. What is benefit of declarative nature? It tells us what it is doing, or we tell it what to do, but not focus on how to do it. And the code begins to read like the problem statement. Let's try to read this code. Given a collection, pick everything that's greater than 3, pick everything that's even, double the values, but I want the first one. So the difference is, if you're sitting next to somebody who understands the domain, and you're looking at this code, and they ask you, what does this code do? Your answer is, I'm still trying to figure it out, right? On the other hand, you read the code out to them, and they are like, cool, that's exactly what we want to do. Hey, but can you make this change for me? And it becomes easy to insert these changes to this code. But this code also is very revealing. So writing a code in a declarative style is like talking to an adult. Well, okay, knowing some adults I know. It's like talking to a responsible adult, right? So the point really is that you are telling what to do and not focused on how to do it. But it also reveals one more detail. And the detail is, when I run this code, notice that in this particular case, of course, I forgot to write those methods, didn't I? So let's go ahead and write these methods real quick. Boolean is greater than 3. All I'm going to do is, given this number value, I want to simply return number is greater than 3. So we can see how the code can actually more or less begin to read like English. So that is a bit of an advantage we have on our hand. Let's go ahead and implement these other functions. I'm going to say is even, of course, over here. And this is going to simply tell me if the number is even, given number is. And then finally, I'm going to say this is going to be just a method called double it. We'll say double it. And all that this is going to do is simply return number times 2. And we can see in this case, in this particular case, is even, not event. So in this particular case, what we can see here is that the result reveals a little bit of a detail. Notice in this case, it didn't give an 8, it gave an optional 8. And the reason for optional 8 is, it says, well, the given input collection may actually be empty, or it may not have any even number at all. And so it kind of reveals the code we saw in the top, while it pretended to work, has some bugs in it. And usually we kind of get reports that we have to fix. In this case, we kind of get to think about it at compile time, or rather the runtime we run at the first time. But how do I get the value out of it? Well, I got to tell you, this is probably one of the most threatening functions I've ever seen in the JDK, because you say or else, and you threaten to it, and then you can pass an alternate value if you're interested to do whatever you want to do with it. So you can see how we can get these kinds of values. This also illustrates another feature of functional style of programming, which is this nice function transformation, where we can transform functions from one to another, and we can write the code very nicely. So this gives an example, one second. So this gives a nice example of how we can compose using Lambda expressions, but we went from imperative style to functional style, and this gives the benefit of expressiveness and conciseness in the code. Did you have a question? Please.
All these filter methods,
Yes.
do they actually iterate over the collection multiple times? Or?
That's a wonderful question. I want to come back to that question in just about 30 seconds.
What do you feel about the duplication in the 3 methods?
Right. Okay, so the duplication as in sample : is the duplication. That's more of an expressive syntax, like calling a function name. So don't look at it as a sample : but it's a reference to say which method are you calling in this case. But the context is very essential for it.
But it is the context of the class you're in, so why couldn't you just...
Right, because it's confusion versus explicitly saying, right? You get it, I get it, but not everybody gets it. Okay, so that's the main idea. Where is this coming from? Because you could have an instance method versus a static method, and all those confusions come in. And there's other issues with expressiveness, confusion, compiler, complexity. So there's good reasons for it. Okay, so the brilliant question at this point is, okay, I'm kind of convinced this may be good, but if you're going to take a collection, create another collection, yet again create another collection, and create one more collection, Are you out of your mind to say this? That's what she kind of politely asked the question, right? And that's a really good question to ask because you don't want to, no matter how good the code is, we're not willing to compromise on performance and create duplication. Well, that's a really good question. And I'm going to answer that question with a slightly different thing. I forgot to mention one thing about the stream. I did mention that streams are a fancy iterator, but there's another feature of stream I forgot to mention. This feature I've only seen among my children. They are lazy to the bone. I go to my children and say, hey guys, you're playing and having fun. Are you done with your homework? Yes, Dad. How did it go? Wonderful. Is everything working? Absolutely. Can I see it, please? Sure. And they run away and I don't see them for an hour. Right? Hey, where are the children? Well, they're working on the homework apparently right now. Right? So that's exactly what streams do. So let's take a look at what's going on over here. You go to the stream and say, hey stream, yes. Filter, done. Filter again, done. Map now, done. Find first, oh dear, we have to really do the work, right? So in other words, stream is extremely lazy. So to answer your good segue into this next thing I want to talk about, there are two kinds of functions in streams. The first kind of function in streams are called intermediate operations. And another kind of functions in the streams are called terminal operation. A terminal operation is the one that rounds up all these lazy guys and gets them to work. So if the terminal operation is missing, then no operation is actually performed. But more so, each of these intermediate operations really do what is called function fusing. So they all fuse into one function in reality. So to answer your question, we don't create multiple lists. So to understand this, let's go back to this example for a second. Notice that we started out with 1, 2, 3, 5, 4, 6, 7, 8, 9, and 10. And if you look at this traditional loop we saw here, in the traditional loop, if you go through the loop itself, you will find out it only performs 8 operations in total. And the 8 operations are compare if it is greater than 3, compare if it is even for each of the elements where it applies, and the double operation. But this loop is pretty good in that it would never ever touch any value greater than 6 or from 6 to further down because 4 already satisfies the result. So this code, as we know, is pretty darn efficient, right? Except that it is hard to maintain, but that's the way it is. But in this case, as it turns out, to the human eye, it looks like a lot of wastage, but thankfully it is not. So let's take a look at an example of this real quick. If we go back here and we say output, and I'm going to say is greater than 3, 4, and I'm going to say number right here. I'm also going to say the same thing here for is even, and then finally I'm going to do the same thing for double it. And let's go ahead and run this code right now and take a look at what the output is. And notice that in the output we notice it did not touch any value greater than 6 or 4 rather also. In fact, it was smart enough to go through and do the operation on 1 because 1 is not greater than 3. It went to 2 and then 3. And then when it got to 5, 5 is greater than 3, it checked if it's even, so it bailed out right after that, went to 4, carried through, and went to find first, and the find first said, hey, this is great, thanks, and they folded the shop right there, right? So it's not doing any extra work at all because of the laziness baked into the stream, and that is one of the really fancy things about streams. So functional style of programming would not be as efficient except for without these kinds of features. That's one of the things I really like about Java is they didn't rush to do things, they took the time to do it. So there are these efficiencies in performance that are built into it fairly well. So we just looked at the laziness of this code. Well, that's great so far, but is there anything else we can do with it? Let's take one more example of this to get a better feel of what we can do with this. So let's take another problem to work with real quick. Let's say for a minute we are interested in not just dealing with these collections, but to do something else with it. Well, let's get to a set of collections of data, if you will. So I'm going to start with a little example of ticker symbols. So I've got some tickers on my hand in this thing called symbols. And if you look at the ticker symbols, I got a bunch of ticker symbols on my hand, about 20 or so of it. So I want to go ahead and find out how these stocks do. And the problem I want to discover here is find the highest stock priced ticker with price less than $500. So that is what I want to do right here. So let's do this using the traditional imperative style we are very used to. So list is, I'm going to say stock info, and I'm going to say stocks. Well, what in the world is stock info? Stock info is simply a POJO, and let's take a look at this POJO, right? Not a whole lot happening here. We got two public final fields. I've got a constructor, and then I also have a toString method that displays the data. So nothing really in the stock info object. Great. So now I'm going to say equals new arrays, array list, and I'm going to create an empty array list, right? And then for, and I'm going to say string symbol, and in this case, the symbol is going to come from the tickers dot symbols. And then I'm going to say over here, loop through each of the elements. Actually, I'm going to go ahead and roll this into a separate function, if you don't mind, so we can actually see it much better. So public static void, and I'll call it we'll call it find imperative for now. So in this case, I'm going to just do that. So within this function, what am I going to do? All I'm going to do here is I'm going to say stocks.add, and I'm going to call stock util.getPrice for the symbol itself. So what in the world is this stock util? Let's take a look at the stock util for a second. Here is the getPrice method. The getPrice method just puts a little delay to even out. I'm going to go to the web here and ask a class called Yahoo Finance to get the stock price. All this class does is it sends the data to the web, gets the result from the web, parses it, and gives us the result. And we wrap that into a stock info object with the ticker price and the current price itself. Fair enough? We don't have to look at the parsing code. There's nothing fun in that. So let's get back to this code. Once we got the stock info, we added that to the collection of stocks. You're with me so far? So that's what we did, right? So the next step, now that we have all the stock prices, the next step is to list stock info, and then we're going to say stocks less than 500 equals, and then what am I going to do? New array list. And in this particular case, we created yet another array list for us to use for stock info. And in this case, we're going to say, given the stock info, we'll again say stocks. Where does this come from? Stocks, of course. And this time I'm going to say if, once again, stock util dot is price less than 500 dot test. I'll explain what that means in a second. And if it is true, then I'm going to say stocks less than 500 dot add, and I'm going to add the stock to it. Now, what does this do? It loops through all the stocks with the prices now, and it tells us if the particular stock we are looking at is priced less than 500, then add it to this new collection. Now, what does this is less than 500 do? Notice this function says, I'm going to return a predicate. A predicate is useful for the filter operation to check if something is true or false. And in this case, this is less than 500 is actually returning a function. So you could argue is price less than 500 is a higher order function. Now, why is this different from the regular functions we write? It's different because rather than returning a value, you're returning a function itself. This is like you come to me and say, can I have a cup of coffee, please? I say no, but I'll give you a coffee maker. You can take that and make yourself some bad coffee with it, right? So the point really is that we are returning a function instead of a result. So now that we have done that, what's the next thing we're going to do here? The next thing we're going to do here, finally, is we're going to say, in this particular case, after looping through this, the last step here is to create a stock info. We'll call it as high priced equals new stock info, and empty with the 0.0. And then we will say for, in this case, again, we have to loop through. So stock info, we'll say stock in the stocks less than 500. And then what do we do with this? We're going to say, in this case, high priced equals stock util dot pick high, and we're going to send it the high priced and the stock we are working with. Once again, if you look at pick high, it simply takes two stock info and returns one. That's all it's doing, right? So given all of this, the last step, of course, is to output the high priced stock. Are you with me so far? So what did we do? We took a list of tickers. We got all the stock prices. That's one list. Then we took that list and reduced that, filtered it to a smaller list with only stocks less than 500. Then we picked the highest price from it. Now I want to run this code, but before I run this code, I want to time this code. So time it .code, and I'm going to ask him to go ahead and time this code. This is going to report to us the amount of time this code is taking. And so I'm going to simply say find imperative. So while I run this code, let's talk about what this is actually doing. Well, we went through this and collected 3 separate collections, and we are trying to find out what stock is the highest stock price and then work with it. Well, that's great so far, but is there a way we can improve that code? Well, notice how we went from one collection to another collection to another collection to another collection and then a value that seems rather inefficient. But the nice thing is it nicely shows us the sequence of steps we are performing. Is there a way to improve that code? Sure. We could reduce all of that into one loop. Right? And with one loop, what will we do? In one loop, we will do everything in there. We'll do the checking, we'll do the getting the values, and once it is, that one loop will be nice, more efficient, but of course it makes it harder to read that code, but that's never a problem because we only write code, we never read it, right? So that's all right. So the point is we can do a little bit of optimization on it. Well, if somebody can note that down, today's stock price for Amazon, which is the biggest stock price among all the stocks, price less than 500, is $335.20. And it took about 22 cents to do this work. Let's go ahead and do this one more time to see how this is going to feel in the more of a declarative style. So I'm going to say code it, time it.code one more time. But this time I'm going to say find declarative or functional, let's call it that, find functional. And in this case, I'm going to pass to it tickers dot symbols dot, and I'm going to say symbols dot stream. So we're going to pass a stream to this function called find functional. So let's go ahead and write this function first of all. So public static void, and I'm going to say find functional, and this takes a stream of string, which is called symbols on our hand. So let's go ahead and first introduce what this particular stream is. So stream comes from the stream.stream. So now that we have defined what a stream is, let's go back to this code and try it out. So what I'm going to do here is output, and I'm going to start out first of all with the symbols. Now, notice we have all the strings of the symbols, but I want from it a collection of all the stock prices. What operation would we use for that transformation? A map. I heard that whisper. Absolutely, a map function. So this is going to say stock util and then get price. That's what I want to call in this case. Great. Now that I have all the stock prices, I want only those prices that are less than $500. What operation would be using for that? A filter, absolutely. So let's throw a filter in there, and I'm going to say stock util dot is price less than 500. Remember how that was returning a predicate, and this guy wants a predicate. This is marriage made in heaven, isn't it? So that's great. And what's the last thing? Well, I'll give you a little quiz to answer this question. Salt is to pepper as map is to... That's correct, reduce. I like this game we are playing. So that's a reduce, so that's a reduce operation. Well, new stock info and empty and 0.0, that's the initial value, comma, and I'm going to say stock util colon pick high, and so we have that output right there. Now, notice this code before we run this. We said, given the collection, get me all the stock prices, filter those less than 500, and reduce it to the high price. Notice again, it begins to read like the problem statement. We went from, let's do a quick check here, 23 minus 6. That's give or take about 17 lines of code, fair enough? To how many lines of code do we have right now here? Pick a number. 1. That's correct. Because, smartly you said, because there's no semicolon in there, right? So that's 1 line versus 17 lines. Which one would you prefer, 1 line or 17 lines? 17 lines, of course. If you're a consultant getting paid by the number of lines of code you write, right? So, but otherwise, we would like to get the work done. So let's see if this actually works, right? What use is it if it doesn't work? So let's fire up the code and see what it's doing. And what was the Amazon stock price? Anybody remembers? Okay, let's see if that's true still. Assuming is the market open? What time is it here right now? Is it 11 o'clock? 12, 1, 2, 3, 4. 4 a.m. 6 a.m. in New York. No, not really. So, not yet. So that price should be the same as it was before. And what about time? Was the time different? Significantly different? Not really. Is the stock price the same? Absolutely. I'm really sorry to say this. Just because you write better code, you don't get better stock prices, right? And even if you get better stock prices, you know who takes the money away. Right? So it never comes to us anyways. Okay, so the point really is, that's what we are seeing here. But the question is, are we done? Can this be better? Let's revisit this problem just one more time, if you will. Let's imagine for a minute, we only have this code right here, right? This code is what we have. Remember this code? In fact, let's make this code better. Let's fuse this into one loop for a minute. So that is the code in front of you, imagine. The declarative code, not really. So we have this code in front of you, that imperative code. And 3 months later, your team comes to you and says, we got a problem. It's like, what problem? The performance sucks. And you're scratching your head, how do we improve the performance? You're going through the code, looking at various ways to improve, and guess what you find? There's really nothing you could do to improve the performance at this point, and suddenly one of your colleagues says, I've got a bright idea. And you are very cautiously saying, okay, but what is it? And your colleague says, you know how we have a multi-core processor? We could use multi-threading. And immediately a thought goes through your mind about your previous job. Remember the job you had? You had a sequential application, and everything was kind of working. You were happily working with it. And one day they said we should use multi-threading, so we introduced threads. And once you introduce the threads, the code looked exactly the same as the sequential code, right? No. How did it look like? Like a monster, right? And it just became really big. And what did you do every morning? You got up and said, I got to go to work today, sweetie, really early because I got to fix that damn bug. And life became really horrible. Remember that time? And what did you do while you were struggling with all those bugs? While struggling with all those bugs, you applied to the other job. That's called concurrency, right? You're like, oh no, thank you. Not for me, right? Well, what if concurrency doesn't turn our code into a monster? Wouldn't that be nice that we don't have to deal with all that things that get really, really bad and ugly? We don't have to do all that extra work. So all I did in this particular case was I simply changed the code from stream to parallel stream. And is the price the same? Absolutely, but I think we got the results much faster. So the point really is, the code is exactly the same as it was a minute ago. As far as this code is concerned, the declarative code is exactly the same. We didn't touch the declarative code. But on the other hand, we got a better performance out of the code by simply making the code parallel stream. This I call as the master switch. I call it a master switch because if you want to go from sequential to concurrent, you are not dreading your life changing the code. You are flipping a master switch. Hey, it's sequential, flip, now it's concurrent. Flip back, it's sequential, right? So you can go back and forth with it much easily. And the benefit of this is, why do we have to do this? Why can't it do it automatically? Because you know what you're doing. You decide whether the code deserves concurrency or not, given a few things. Is the problem really large enough? Is the data size really large enough? Are you going to be saving time going to concurrency versus trashing by going into concurrency? You can make the decision. You can make the decision not just at compile time, you can make the decision at runtime. Based on the data size, you can put a condition that says send a stream or a parallel stream, but the rest of the code is going to be exactly the same. But of course, you didn't get this for free. You get this out of one thing that's in short supply in this world, that is by exercising what's called discipline. And the discipline is to keep those functions pure rather than making them impure and messing with a lot of stuff in it. So by doing some of these things, we can get a nice benefit in terms of how we implement it. So we looked at a number of things. We started talking about how we can transform the code from the traditional style to a functional style using Lambda expressions. We talked about imperative versus functional style or declarative style of coding and how that helps. We talked about composing functions as well. Please go ahead. The question is, can you configure the number of threads? The answer is, yeah, okay. Well, the problem here is this. You can actually configure that. By default, it uses the number of threads based on the number of cores you have. The configuration is done at the moment at the JVM level as an option. I would almost be certain that's going to change in the future. We would have more control. We're not there yet. So that's the two answers. Yes, it is implemented default. Go ahead, please. Is there a performance cost on the parallel streams? Yes, there will be. Yes, yeah, you definitely don't want to do that because there would be a cost of thread and composing them. So that's why the master switch is given to us, and we get to pick it, but we don't want to go into that. And there are certain problems that simply don't make sense to put in parallel stream because the ordering of operations may actually make a difference. So we still need to control that, right? So that's why the switch is something for us to use. Don't put it on autopilot. We definitely need that control. Yeah, please. What happens if the thread dies? We have to mourn. Yeah, really, really. Well, that is still a problem. We have to do fairly good exception handling. That is always a concern. That kind of takes us to fun things like reactive programming, where resilience is something we think about, but that's something for us to worry about. Good questions, but unfortunately I'm out of time. One more. I'll stand by if you want to come and talk. I'll be more than happy to listen to you. If you're interested in downloading the code examples and this topics list, they are available in this URL. As you saw, I did not use any slides, so I have no slides to give out, but that URL contains the code examples and this topic list. I really hope you found this useful. Thank you.